Next up, we have Jiten Sardana, Amazon USA. Mr. Jiten Sardana is a software engineer at Amazon, where he designs large scale regulation compliant systems across global trade and healthcare. He has led the development of platforms that have classified over 80 billion products and built secure, HIPAA compliant healthcare notification systems used by millions. With a focus on privacy, automation, and compliance, Mr. Jiten blends technical innovation with real world impact. His work safeguards user rights, optimizes global operations, and exemplifies how engineering can solve complex regulatory challenges at scale.
Thank you, Manji, for the intro. Again, yeah. So, good morning. Good good morning, everyone. Thank you for joining today's session. Today we're going to talk about tokenization in healthcare systems, and which is like a pathway to securing the data communication between different entities that are involved in the healthcare platform. So, yeah. This is like a very increasingly critical topic, how the security approach is revolutionizing patient data while streamlining all the compliance that is involved in the healthcare systems, given that we have been digitizing healthcare in 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 the times. Yeah, so before we start a quick overview, I'll walk you through the challenges we face, explain how tokenization works, compare it with other methods, show real-world impact, and then finish with practical implementation insights. So, yeah, let's begin with a pressing challenge of how do we secure patient data in today's world. So, before you jump into that, why do we need data? Why data needs defending now more than ever? So here's a startling fact. In 2024, nearly two major healthcare data breaches occurred every single day, resulting in over like 364,000 patient records exposed daily. Uh, Consider that scale. It's equivalent to millions of sensitive records leaking every month, which is and you might be wondering like why healthcare is such a prime target. It's because medical data combines personal identifiers, insurance, credit card info, medical histories, making it far more valuable than say a credit card number alone. And at the same time, regulations like HIPAA, GDPR, PCI, DSS are becoming more comprehensive and demanding more rigorous protection. But still, healthcare and given that there are a lot of systems involved in healthcare which have to interact with each other to maintain these smooth patient care workflows. This demands innovative and robust security solutions. That that's where it leads us to tokenization. So what we'll discuss what exactly is tokenization. So in simple words, tokenization replaces sensitive data such as patient IDs, medical records, or payment information with random, meaningless strings, values, or they're called in uh, tokens. So this token has no mathematical link to the original data. It's making it useless even if it's intercepted. The actual patient information is stored in a highly secure token vault, which is a database that's encrypted by a couple of different encryption algorithms. Could be yeah. So think of it this way, like the token is a placeholder or proxy. It's used everywhere in the systems and processes, but the real treasure is locked away in a secure box, if you must say. So yeah. So let's look at how this practically works in a healthcare setting. So here's a typical end-to-end workflow in a healthcare system where a patient starts their journey when their data is collected, say during registration via electronic health records or billing portals, or let's say telehealth visits. So the tokenization engine generates unique tokens, unique random tokens to replace the sensitive data immediately. After that, the original data is stored securely inside a token vault, protected by strong, like again, I said, cryptography, strong encryption, and access controls, so that any access can can be recorded. And then throughout the entire organization, billing, labs, analytics, and any external partners on and to any external partners, only these tokens are transmitted uh, or as well as stored. So whenever required by the staff or the systems, do tokenization can be performed at runtime via the vault that is used to store these tokens and retrieve the original data. Um, and again, all of this is being logged strictly and done in oversight of these permissions. So the key benefits that originate with this are that sensitive data never leaves the vault. Tokens are tokens flow freely between the systems, and safety is maintained across all of these. Then strict access policies and audit logs help maintain this regulatory compliance in case required. Um, with this understanding, next we'll compare tokenization with other common data protection methods, which are encryption as well as data masking. So, if as you can see in the slide, there are all of those three are mentioned, and then there are a couple of rows which explain what are we comparing against. So, the first part is the key management thing, where tokenization key management is basically to generate a token or encryption, do you need any key? So tokenization, as the name states, it does not really require any key to generate a token, which means there are no risks or complexity from lost or stolen keys. Encryption, however, like really depends on what kinds of keys are you using, and if they are compromised, that exposes your data as well. Data masking is just masking your data so that it's not visible in plain text whenever it's shown on your user interface. So again, it does not involve any keys. And then next part is reversibility, where tokenization can only be reversed if you have the mapping between your token and the plain text data. And that mapping, again, is stored in your secure vault and can only be accessed through proper authorization. Encryption, however, is reversible if you get the correct key from somewhere. And data masking, reversibility, not reversible, but yeah, it's either it permanently hides the data or it does not hide the data, and it's only visible on the UI. So um, then security level, tokenization provides very high security, even if like tokens leak, they are meaningless in themselves unless you have access to the token vault. Encryption's security depends entirely on the secrecy, and masking offers like moderate security. It mainly protects against casual observation rather than actually securing the data. And then compliance. So tokenization reduces the audit scope as well as the compliance complexity, implementation of compliance complexity. However, encryption requires wider audits. You have to do key management, you have to perform regular scrutiny, and um, coming to masking helps with privacy, but it's a limited it offers a limited compliance relief. So all in all, if we see that tokenization lowers the risk, reduces the operational burden, and then simplifies regular audits that we need to perform for various kind of regulations. So with that comparison done, let's get technical and discover what happens inside a token vault. So as I have mentioned previously, token vault actually stores your the token value and the plain text, the sensitive data against it. So here's the tokenization's token vault. Since token vault is like the core of their tokenization securities architecture. So here's what makes it strong. Here's what makes it strong. Tokens are generated with cryptographically strong randomness so that no one can guess or reverse engineer them. So for example, you have my first name, say like Jiten, and you create a SHA-256 hash out of it. So that's a very unique hash, and it's very hard to reverse engineer that hash. Like even if you try to do it, you would probably need like um, a supercomputer or let's say a quantum computer, given that we're progressing towards that. So that hash can serve as a token value wherever my name is required instead of directly using the value. And that value is strictly isolated within the vault. No single system or database ever holds both tokens as well as their underlying values simultaneously. So this is done to avoid rainbow table attacks where hackers can try get publicly available tables and run them against your vault, which has been exposed through some APIs, which has been exposed through some APIs to get the values or to get the hashing function that you're trying to use. Then access to the vault is tightly controlled via multi-factor authentication. That this could include your 2% reviews, SMS authentication, and now passkeys, OTPs, that sort of things, as well as detailed role policies, which only allow some actors to get access to the vault and not allows everyone. Um, so role-based access control. And then every action in the vault, whether it's token generation, detokenization, access requests, is fully logged to maintain audit trails as well as regulatory compliance. How do you integrate with token vault? This can happen through anything that you expose your token vault through. It could be the REST APIs, RPCs, which is report procedure calls, um, any kind of network access that you might grant your token vault to. And all of this is again secured by TLS, OAuth, and role-based access controls. So for ITDs, this means there's seamless but highly secure connections between your systems and the token vault. And this forms the foundation of modern healthcare data security. Yeah. So next we are jumping on to security and compliance benefits. So what what would happen in real terms if a breach were to occur, or if we're in terms of tokenization, if your tokens get hacked, hackers get access to your healthcare network, they'll get the tokens, not the actual patient data. Since tokens are meaningless outside of the vault, breach impact is dramatically reduced, along with financial penalties that might be incurred by an organization, and as well as lots of patient trust is minimized because only the tokens have been exposed and not the actual data. So from a compliance standpoint, tokenization narrows the regulatory scope, and instead of securing every system in your pipeline, you can focus and can center on protecting the vault itself rather than every system that's involved in a healthcare or a financial pipeline. So further, you gain granular access control, enforcing the principle of least privilege. Again, that's the first and foremost principle from a security standpoint. And then safe and compliance data sharing can happen through to labs, payers, external vendors, whoever's involved in your healthcare chain. And that becomes practical. That actually becomes practical because only the tokens circulate between the systems and not the actual sensitive data. So that's why tokenization is a foundation of enabling like the modern healthcare, which is the digitized version of healthcare that we have been going through. And then what are the actual use case scenarios of tokenization? So from a healthcare standpoint, tokenization touches nearly every patient data interaction. So it starts with patient registration, where the patient information, such as their IDs, are tokenized immediately for EHR and data exchanges. Um, For EHR and data exchanges, only the tokens flow between the internal and external systems, closing down some of the network vulnerabilities, such as man-in-the-middle attacks. And then in telehealth, which is when you call your doctor on the phone or a video call, which has been growing lately, tokens safeguard spread patient information by during their virtual visits. So, and again, for billing and payment, the original industry from this, from where the tokenizations systems gain popularity. Tokenization of financial information reduces the PCI DSS scope as well as the fraud exposure. And then finally, all detokenized data can is tracked and monitored for auditing purposes, thus also enhancing your security. So think of tokenization as an invisible shield working silently behind every patient touch point. And if you work in any of these areas, we are already touching the systems that stand to benefit from tokenization. So next part, we're going to discuss the regulatory alignment. So there are a lot of regulatory frameworks around the world. So and tokenization helps us ensure that it touches major regulatory frameworks, and it helps us ensure that we are in compliance with all of these. So some major ones are HIPAA, which is a healthcare framework, regulatory framework in the United States. So tokenization minimizes breach risk, reduces reporting requirements, and helps narrow the audit scope. For GDPR, which is applicable in Europe, tokenization enables data minimization principles, helps enforce patient rights, including the right to erasure, and which means a patient can request that the data be erased by the holding company, and then streamlines compliance reporting. Then PCI DSS, where tokenizing payment details, we can shrink cardholder data in the environment, again, lowering our audit burden as well as reducing our fraud risk. So the bottom line here is that tokenization can form a unique compliance approach, making security, privacy, and audit more efficient. So, sorry, yeah. So how do you how do you actually get it to work for you? So yeah, so there are some decisions that you have to take. There are some decisions that you while designing any system, there are some critical decisions that you have to take when you start building a system. So whether you will deploy your tokenization system, so here whether you will deploy your tokenization system in-house or go for a trusted vendor or cloud providers. Each has its pros and cons, expertise. So again, should your token vault be cloud-based, allowing scalability and flexibility, or should it be on-premises for tighter physical control? Um, as you might know, like if data centers also get hacked every once in a while, so having physical control also makes sense for this kind of data. So again, then Start start with your highest risk data, such as patient identifiers, payment information, then expand as the program matures, rather than start considering everything at once, because that will complicate your software building process. Then define token life cycle policy. So, for example, how often your tokens will be rotated, how often they will be refreshed, what will happen once a token is refreshed or once a token gets expired. So again, for any kind of security applicability or security feature, governance is the key. So human touch points are always like the points of most failure. So rigorous staff training, continuous security audits, and as well as policy enforcement are the key processes that we have to always keep in mind to drive long-term success. So remember, security in these kind of systems is always is a continuous journey and not a destination. So what's in the near future if we talk about tokenization? So for example, we are living in the AI world where Gen AI is taking over all of our processes, manual processes. So by 2027, we are envisioning that AI-powered adaptive tokenization may dynamically change tokens at runtime based on risks, threats, as well as intelligence. From intelligence, I mean like if our data gets leaked, then based on what our tokens have gotten leaked, it changes based on those. Then by 2030, distributed token networks will support seamless, secure cross-border healthcare data exchange. And we have seen this already happening in some of the industries which are related to um, cryptocurrencies where tokens are again used extensively. And then patient empowerment, with this, patient empowerment will grow, and then tokenized consent systems, allowing individuals to directly control who accesses their health data and when. Right now, it's your health data can be accessed by whoever is in control of the token vault rather than you deciding who can access it or not. Then, yeah, so tokenization isn't just a technology, it's like the foundation for a future of secure, trusted, patient-centric healthcare innovation. Yeah. And yeah, so this is the slide that talks about the future scope of the tokenization systems. And oh, yeah, thank you everyone for joining this. And remember, tokenization transforms healthcare security from to any kind of security from reactive to proactive, and it reduces breach risk, streamlines compliance, and enables data sharing while maintaining patient trust. So, thanks everyone for your attention. And yeah, thanks,
Thank you,
Himanshi.
Mr. Jiten Sardana, for your insightful talk. Your session on tokenization in healthcare as a pathway to secure patient data communication shed light on the vital role of data privacy and security in modern medical systems. We truly value your contribution to ICCCNet 2025.